In this video, we're going to be discussing graphs of radical equations. So, we've done a bunch of graphing before, and we're going to continue some of the graphing stuff we've done in previous units with this. And we're going to be talking about two different types of radical equations. We're going to be talking about graphs of square root equations, and we're going to be talking about graphs of cube root equations. So square root is obviously y equals square root of x, and it has this kind of curved shape that has one endpoint and it continues on forever in the other direction. And a cube root, if you look at it, it kind of just looks like if you took the square root and mirrored it over the x or over the origin, and you got this kind of curvy shape. Okay, so it kind of looks like the cube root, this part here kind of looks like the square root, and then this part over here is kind of like its mirror image. Okay, and that's how we can kind of tell this is square root, this is cube root. Notice the square root has an end point, and the cube root doesn't have an end point, it has a turning point. So you can see that this one opens up, and then at this point it turns and now it's opening down. So we call this a turning point, or another word for that is an inflection point. So what I want to do is I want to be able to look at a graph, and I want to be able to fill in all of our characteristics. Now we've done this sort of thing for all sorts of graphs, so it shouldn't be any big surprise for anybody. So here I've got the graph of y equals 2 times the square root of x plus 3 plus 1. And I've already graphed it for you. And we'll discuss in class how to use the graphing calculator to graph these. But I want to fill in all of these characteristics. So first off, the domain. Now this graph has an end point here. It starts here at, what is this, -3, 1. And it goes from there. So my leftmost point is -3, and my graph continues forever. So my domain, is going to be -3, and that shouldn't be a parenthesis, that should be a bracket. So my domain is going to be from -3 to infinity. Now also my range, if I look at this, this is my leftmost point and it's also my lowest point. So my range is going to be from 1 to infinity, because it starts at 1 and it goes up forever. The end point or turning point. Well, this has an end point. It ends right here. So my end point is at -3, 1. And then my end behavior. All right, so we're going to have end behavior on two sides. We're going to have our right end behavior, and we're going to have our left end behavior. So on the right side, this graph continues to go on forever to the right, so that's x goes to infinity. And it's also going up forever, so f of x also goes to infinity. On the left-hand side, it doesn't go on forever, it stops right here. So because it stops right here, we have an endpoint, which means on the left-hand side, we're going to this point. So x is going to -3, and y is going to 1. For increasing intervals, well, if we look at this graph, it starts here, and it just keeps going up forever. So the increasing intervals is basically the same thing as the range. It's from -3 to infinity. Remember, increasing, decreasing, and constant is always x values. For decreasing interval, well, it's never going down, so it just doesn't have one. The intercepts, okay, this has one intercept. It's right here. Okay, and it's kind of hard to tell from this graph, but it is 0. So it's a y-intercept, so it's 0. And I don't actually know what the intercept is right here. It's 4 point something. Yeah, I don't know off the top of my head what that is, and I don't have it written down, but you can see where it's at. It's 4 point something there. All right, so let's look at example 2. This is a cubed root function. You can see it's got that sort of wavy shape to it. This is y equals the cube root of x minus 2. All right, so once again, we want to do same characteristics. Okay, this graph is continuing forever to the left and forever to the right. So for my domain, because it's going forever one way, forever the other, my domain is from -infinity to infinity. For my range, well, this side is pointing down, this side is pointing up, and they go on forever. So my range is also negative infinity to infinity. For my endpoint slash turning point, this has a turning point, and that turning point is right there. And that point is 2, 0. So we can just see where it turns from facing up to facing down. For my end behavior, well, because I have this arrow on the right-hand side, okay, I have an arrow going to infinity for x, and because it's pointing up, that's also infinity for y. On the left-hand side, I have an arrow going left, so that's x is going to negative infinity. And because that arrow is also pointing down, then y is also going to negative infinity. Now, increasing intervals. Okay, this is kind of interesting. If I go from left to right, you can see my pen is going up, 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 still going up. I hit this turning point, and even though the curve of the graph changes, my pen is still going up. So this is actually increasing from negative infinity to positive infinity. It's always increasing. When is it decreasing? Well, if it's always increasing, then it's never decreasing. As far as intercepts, it's got 2 of them. Okay, this one right here is obviously 2, 0. And the other one, okay, which I don't have written down, but I know it's 0 and it's negative 1 point something. Okay. In class, we'll talk about how to use the calculator to come up with it, but right now you just need to know how to see it on the graph, and that's kind of a weird decimal here, but it's negative 1 point something. So basically, this is all stuff we've discussed before. The only thing that's different is being able to identify the endpoint or turning point. So I'm going to leave you with this try-it problem. I want you to fill in the characteristics of this graph. The graph is y equals negative square root of x minus 2 minus 2. And you need to fill in all of these traits of this graph.